Okay, so I'll start with a quick poll so I understand the audience a little bit better. So with a raise of hand, who here has no knowledge of how Kafka works? Okay, cool. And who has some knowledge, he knows a little bit about how Kafka works? Great. And who is working with Kafka in production? Okay, cool. Thank you. So welcome, everyone. My name is Natan Silnitsky, and I'm a backend infrastructure developer for the data streaming team at Wix. And this talk is going to be about the Wix ecosystem on top of Kafka for event-driven architecture. And you will see the best practices, tools, and SDKs that we have created in order to be able to scale our distributed system to more than 1,000 microservices. So a few extra numbers, the last numbers for today. So specifically for our backend, we have around 300 developers and more than 1,300 microservices, and more than 10 million lines of code, mostly in Scala, but also we had Java and .NET. And we produce around 850 million Kafka messages every day. So it's not as big as the Wix scale that Avi showed before, but it has grown tenfold over 2.5 years. Why 2.5 years? Well, that's when we started measuring this metric. And that's what we have today. But we do have a lot of scale concerns around Kafka. We need to serve many developers, as you can see, and a lot of different use cases serving different microservices. And we'll touch on that in the talk. So we'll focus on our inter-service communication story, or how we move to a more event-driven architecture. So if we go back to until 2014, we used JSON RPC, synchronous. For our retry scheduling, for error handling, we used to use ActiveMQ. We chose it because it has an embedded JMS broker, so it's easier to do integration tests with it. You spin it up and do easy testing before the time you can set up Docker very easily. And we suffered a lot of production issues with ActiveMQ. So in 2015, we started using Kafka. Sorry. And we looked at the Kafka SDK for the client, and we noticed a lot of boilerplate and missing features that we required. So we decided to wrap Kafka with our own library, called it Greyhound. And the reason was we wanted to make things simpler and abstract away the Kafka details for our microservices, and also add more features. And just to complete the picture, in 2018, we moved from JSON RPC to gRPC, which is a more modern protocol working with HTTP2. That means higher throughput, higher performance, and also allows for working with more than the JVM languages. So it utilizes protobuf, meaning that we can serialize and deserialize for any language we basically want. That meant that we introduced Node.js at Wix for our microservices. And our architecture at the moment is pretty much a hybrid architecture. We have both the gRPC and, of course, REST endpoints together with event-driven using Kafka. And one of our discussion groups is going to be about when to use request response, when to use event-driven trade-offs, challenges, and will be led by Avi to discussion. Okay, so like I said, we decided to wrap Kafka SDK with Greyhound, and it meant, sorry, it meant that it was really easy for us to scale our microservices usage of Kafka very easily, because any change we made just for Greyhound, and it immediately propagated to all the services. And now we'll look at why we chose Kafka. So basically, we chose it for its flexibility, performance, and scalability. And for those of you who are not that familiar with Kafka, we'll do a very quick introduction. So Kafka, basically, you can think of it as a message broker, where you have like a service that will produce messages to it. The messages are directed to specific topics. Each topic is divided into partitions. And you can think of these partitions as append-only logs. So the producer just appends a new message at the end of this log, meaning quite high performance because it's a very simple operation. And it's done, and on the other side, you have a service that consumes the message. Unlike message queues, that once you consume the message, it will be removed from the queue. With Kafka, you just continuously, sequentially read the messages in the partition. Each consumer here is reading at their own pace. And once you're done with processing some message, you commit it. So if you restart or you reassign, then you will start from the last non-committed message. So using Kafka means that you get faster performance because sometimes you will read this partition in memory inside the Kafka broker. And also, it's really easy to scale up because all you have to do is increase the number of partitions and you have more and more parallel processing and higher throughput that you can handle. And now I want to focus on Greyhound features and why they decided, deep dive into why we decided to wrap the Kafka SDK. So the first thing they noticed is there is considerable setup boilerplate with Kafka. So you can see here an example, a Java example of creating a Kafka producer. The more interesting properties here is where's the location of the broker for the producer to communicate with. And also, if you want to work with typed messages, just work with types, you need to provide the serializer that you use for each of these types. And the other properties here where you need to, if you want to, you can use the defaults, but maybe you want to tweak them for best work optimally for you. And if we look at the Greyhound equivalent, it's much simpler. It's a simple builder that creates the producer, and it has flavor for unordered, ordered, or ordered processing. And everything is hidden here because you don't really need to set it up yourself. It injects the broker's location automatically, and it knows when is the best time to commit the messages that it processes. And another thing here to note is, I don't want to repeat myself, so the consumer side is really quite the same here. You also specify the broker location and serialization, so it's pretty much the same situation. Okay, so the second thing is the consumer API. We have the Kafka consumer side. How do you do it with Kafka SDK? Well, you've created the consumer. Now usually you'll have while true loop. You decide how many messages you want, up to how many messages you want to fetch. And then you do sequential processing here for these messages. For each of them, you write some processing logic. And then you can decide when to commit the messages. So you can also use the auto-commit feature of the Kafka consumer, but then you may end up with more processing, double processing, than you would like. So here in this example, you commit after you've finished processing all the 1,000 messages. So let's look at how Greyhound does it. Basically, you just specify for the consumer builder a lambda with your handling that you do. You don't need to specify when to commit because once all the handler invocation finishes, that's when Greyhound will do the commit for you. So simpler. Okay, we talked about these two issues. Now let's see a first use case at Wix. So it's the classic publish subscribe. We have the Wix editor service here, and it serves our Wix users that edit their sites, and sometimes they click publish when they want the site to be, the new version to be available for the world. And you can see here that this is a protobuf message, HTML site published with a revision and site ID. And the Greyhound producer can easily serialize it. It uses JSON behind the scenes. So it processes these protobuf messages and serializes them. And over on the Greyhound consumer side, we have several services here that consume these messages. It can be like Wix Vertical, a store, or maybe a restaurant, stuff like that. They specify in the handler the same type, HTML site published, and they can do any kind of handling they want with the Greyhound consumer. So it's pretty straightforward use cases for a start. What about some interesting features that Greyhound introduces that Kafka clients do not have? Well, let's look at the next use case, high throughput. At Wix, we render our sites, our users' sites, for visitors on the server side in order to get faster loading time. And they are, of course, utilize heavily the cache. Each time they finish rendering, they put it in the cache. And this cache is spread out all around the world in many, many data centers, so that the visitors can get much faster load time. And sometimes this cache needs to be invalidated. Maybe a new version of the site was published, or maybe some code change was made for any of the components of the site and stuff like that. So in this case, the server-side renderer service will produce a Kafka message to purge a site from the cache. And you can imagine that this happens quite a lot at Wix. So it has around, on average, 100K RPM, requests per minute. And we have a service called Gurnished that handles all these cache invalidations. It uses the Varnish third-party service that handles it for us. So it needs to consume these messages and request Varnish to invalidate. So let's say we put 10 instances, 10 pods of Gurnished in each of our data centers. That's already quite a significant number. But what about the consumer? So we can do sequential processing, but we're going to have a lot of partitions for each of these instances. So that's not a very good utilization and pretty low throughput. You can create multiple Kafka consumers to handle, but that means that you won't have very good resource utilization because it has quite a lot of overhead. So what we do with the Greyhound consumer, we just offer our own parallel consumption feature, which simply means that the Greyhound consumer has a worker thread pool behind the scenes, which each worker will get messages from different partitions, and will process them according to the same Kafka semantics. So on the code side, you can see here that's really simple to specify. Here for Gurnished and the purge site message, the maximum parallelism is 40, which means that the Greyhound consumer will see how many partitions Kafka gave him, and then according to that, it will create the amount of threads, not to go over one thread per partition, and not to go over this number. So we get quite a higher degree of parallelism with less overhead than using Kafka consumers. OK, cool. So what about error handling? We want to have resiliency. We want our users to have a good experience, or at least a degraded experience, but not to suffer problems, not to suffer in their experience because something is problematic on our business logic. So Greyhound Consumer offers the ability to have retries. So let's look at the following use case. We want to guarantee the successful completion of our business logic operation here. So we're looking at the Wix payment service. This Wix payment service allows for processing of payments from the site visitors to our site owners, our Wix users. So we have the job scheduler that requires subscription renewal. So some of our site visitors have a monthly subscription or something like that for payments, and sometimes this subscription needs to be renewed. So the job scheduler sends over to the Wix payment service renewal request. And the first thing that the service will do, it will produce the message over to Kafka in order to know that it will not go away. And the next step is to consume it, Wix payment service itself. And it will specify that it wants to retry in case there's some business error. So the job scheduler can forget about this job because it knows it's already in Kafka and it will be consumed, and it doesn't have to worry about it anymore. So that's a very powerful thing. And how do we set it up? So basically, we'll introduce a retry policy and set up the intervals between retries. 1 second, then if it still fails after 10 minutes, and you can add more. And if after a long time it still doesn't process, you can put it in a dead letter topic and then review it manually and decide what you want to do with it, reintroduce it or not. And then with our famous builder that we saw earlier, we just add this retry policy and we get it automatically. And behind the scenes, the Greyhound consumer, in case of failure, has a retry producer in the consumer itself. And when we introduce the retry policy in code, it means that we'll have created retry topics in Kafka. So for each interval, we'll have a separate retry topic. And the producer will produce the message upon error for the first retry topic. And if it fails, the producer will then produce it to the second retry topic. And using retry topics was inspired by Uber that have a very similar solution. So we'll have as many retry topics as intervals that we chose. It means that we can have quite a lot of topics and partitions. Basically, with Kafka, the recommended amount of partitions per single broker is up to 4,000, which means you can end up with quite a lot of brokers. One thing you can mitigate this with is to just have one partition per retry topic, because statistically you will have much less processing usually of errors, and you don't have to have the full partition amount for the original topic. There are other ways to implement retries with Kafka. I don't want to get into it, but there are trade-offs in any case. No solution here is the bulletproof. And one last point about retry topics, you'll get out-of-order processing. Why? Because once you put the message in a retry topic, the next message in the original topic may succeed, and then it means that you have out-of-order processing. So what if you have a use case, like the use case here, that really wants to have sequential processing and never get out of order? Here we have the build log service that puts all kind of metadata information about our build situation in order for other services to consume. And it consumes updates from GitHub, from the source control update topic. And it mustn't process this out of order, because then there'll be some corruption in the state. So with Greyhound Consumer, you just specify a blocking policy, which means that the same message upon processing error will retry. Now, what happens if you keep blocking on the same message? You can introduce a lag, meaning that the producer keeps producing messages and higher offsets, but the consumer is way back, and a lag is building up. So in that case, we have an alert and a dashboard for each of our services automatically. So the developer of the service can go to this dashboard, view the message that failed, and then decide if they want to release the message because it's not really an interesting error, and then the lag will be reduced, or they notice there's a bug. So all they have to do at that point is to go and fix the bug, deploy their service again, and because we know with Kafka, it will just get it will reprocess the same message because it's the first one that was not committed yet. And hopefully, the bug was really fixed, and the messages will be consumed again, finish processing successfully, and the lag will go away. OK, good. So we handled errors and problems on the consumer side. What about the producer side? We can have situations where the Kafka broker is unavailable. That can happen. So for instance, for our previous use case that we looked at with the Wix payment service and subscription renewal, we can have a situation where we produce the message, but we fail to produce it because the Kafka broker is unavailable. It's a really extreme situation because there's we have several brokers available, etc., but this can happen. So for that, Greyhound introduced the resilient producer, and it's basically just gets the message to our file before it gets to Kafka broker. It's a simple H2 file database. So the message is saved over there, and then it will be fetched from there, and there will be retries on failures. And there are two flavors. One of them is ordered. So in case you decide to use ordered producing, then if the message fails, then it will continue to block on the same message and retry. But you can also do the unordered producing, and then it will not wait for failures, and it will keep trying with the following messages. So it's better throughput and also better resiliency, because if it's unordered and there's some maybe issue with the current file, it can bypass the file and go directly to Kafka broker. OK. One before last feature with Greyhound is context propagation, which is very important for us at Wix. Let's look at the following use case. We have a site visitor that wants to sign up for the site, and it has all kinds of information in the HTTP request, like what's the IP address, what's the geolocation, etc. So the request comes into the site member service, and at this point, the site member service will produce the message to Kafka for consumers of other services to handle. But Greyhound will automatically produce all the user request context into this message, which means that, let's say we have our contact service that handles all the contacts for the site owner to handle. You can really have a lot of business operations in your own back office as a Wix site owner. And it's really easy for the contact service through the Greyhound consumer to get all of the request information automatically and store safely inside the database whichever information it needs, maybe the location like I noticed before, and user identification, etc. OK, one last Greyhound feature is matrix publishing. So that's very important for production monitoring and debugging. And we have quite interesting matrix that we have on top of what Kafka has to offer in itself. For instance, we have a metric for seeing what's the longest running handler at the moment. Maybe we have some handler that's stuck and causing lag, and we want to know about it. So the Greyhound will publish these matrix, and then our matrix server, in our case it's Prometheus, will poll these messages, this matrix, and Grafana will then be able to view, show them. So we have automatic dashboards for each of our services. We have a new service, automatically it gets a Greyhound dashboard, and you can see all kinds of interesting metrics, like I mentioned, with longest running handler time, and with building up lags, and maybe errors in producing and stuff like that. And then we also have automatic alerts for our developers. So for instance, if there's some issue, you can get a Slack alert into your team's Slack channel. And also for our, we use the Ops Genie third-party tool. We have it in our phones and our apps. Okay, so that was about metrics and monitoring. So we covered quite a lot of Greyhound features. We have easy setup and simpler consumer API, thread-safe parallel consumption. We handle retries both on the consumer and the producer side, and context propagation for our HTTP originating requests, and matrix for production monitoring. So Greyhound takes care of the mechanics of distributed systems, so usually it's the Wix developer up till now, can focus on writing the business logic. And this is how we use Kafka, similar to Greyhound, is the topic of the second discussion group. So the idea is to introduce each company's way of using Kafka and describing your challenges and your use cases so we can all learn from each other. And that's going to be moderated by me. Okay. I'm excited to say that we are open sourcing Greyhound, and it's open in alpha at this stage, starting from today. And if you are interested in checking it out, so come to us. We're not yet completely publicly opening it up because it's still in alpha, but it will also shortly be in beta, and we are very excited about that. And one last point about Greyhound, we have also a test kit that we use. We have quite a lot of integration tests at Wix, and this simplifies things. When you use Greyhound test kit, you just have embedded Kafka brokers and Zookeeper start up automatically, and you get injected into your code the location of these embedded services. And then you can also understand if you produced your messages correctly in tests, because it offers a message sync, etc. So we have a lot of tests, and this is very important for us. And with our continuous integration system, which is on top of Bazel, and I think it's going to be the topic for the next meetup of this at-scale series. Bazel means that you continuously introduce new code from source throughout all the code base at Wix. And, well, specifically with Bazel is for the JVM code currently, but we do want to expand it for Node.js as well, which means that you get the Greyhound updates continuously for all of the dependencies, all of the services, and it also gets possibly automatically to production if the service hasn't been deployed for a while. It will get there automatically. So we know that our production environment has the latest bug fixes, the latest updates continuously, so we can sleep better at night. Cool. So now I want to switch over to more slides about architecture and design. The first topic is but all around Kafka, yeah? So the first topic is, if you want to have a completely distributed and event-driven architecture and design, I would suggest that using Kafka and using WebSockets can get you there. let's look at the following use case. We have a long-running asynchronous business process. So in this case, we're talking about contacts importing. Your Wix site owners, the Wix user we call them, may want to import contacts from Google or something like that, and they want to handle everything in their back office. Now, this process can take quite a long time. So we don't want a user to wait in the browser until the contacts importing finishes. I mean, so if you put some REST request here and just wait on it and get back the response, it could be quite problematic. So we decided to introduce a WebSocket service here that we created at Wix. So the first thing that will happen is the browser will subscribe for notifications from the WebSocket service on a dedicated channel ID. Then all you have to do is get the browser to request importing of CSVs or import from Google, or all kinds of scenarios for the contacts job service, which produces the messages to Kafka. And you can see here that not only is it a long business process, it also spans multiple different microservices. So you can have a cascading gRPC and REST request, but it will be less resilient and less error safe. Now, once the message is produced to Kafka, the context importer that actually processes these jobs can consume the messages at its own pace and do the long processing that is required. Maybe there's another service there. But basically, once the entire process is finished, the only thing that remains now is to notify the WebSocket service that the process was finished with the same channel ID that the browser code subscribed to. And the WebSocket service will know how to get this response back to the browser for the exact, for the needed location. And then the browser UI can update according to the status. So you can see here that this system is completely distributed, and it can be with multiple services. But using Kafka and the WebSockets means it's completely event-driven and more resilient because you have the intermediary in the middle of the Kafka broker. And also the WebSocket service has a lot of error handling by itself. And you have this decoupling. I really like this way of architecture, and I recommend it. Another interesting use case we have with Kafka is we use it for key value stores. So you can have the topic either retained over time. You can have the messages inside the partitions retained infinitely if you want. And you can also decide to use the topic as a compacted topic, meaning that old values of the same keys will be deleted. So it can basically be used as a key value store. We only use it for sizes that can get inside memory and require very, very high throughput because you can access it in memory. And so we wrote a specific code for this. I don't want to get too much into it because it's out of the scope for this talk, but there's also this option with Kafka for using compact topics. And of course, like I mentioned before, and Avi mentioned, we're in a multi-data center environment across the globe. And sometimes you want to replicate the topics between the data centers. And for instance, if you want to replicate the key value information, that's one example. So we created our own replication tool. We call it Raven. We created it at a time with the Kafka Mirror Maker and replicators that weren't really mature enough and handling all of our requirements. It's quite a simple design. You just use the Greyhound consumer, but it's just a dynamic consumer that can get subscribed to more and more topics dynamically as it needs. Has a lot of partitions, obviously, for each of the instances. And then it will consume a message from one data center and produces to the other data center according to what the users configured. So quite a simple design here. And I want to share with you the design behind the scenes because it's quite interesting. So the requirement here with the topic configuration is to fetch the topic metadata from all of the DCs. But we serve that page from one of the DCs, right? So we have the Greyhound admin server. It got the request over in one specific data center. So it utilizes Kafka, and the first thing it does, it puts the requirement to the command to fetch the topic configuration from all the data centers into the Kafka partitions, the topic. And now it will consume it by itself because it can serve for its data center the topic configuration. And utilizing Raven, the replication tool, we can have this command also replicated to the other data centers. And then the instances in those data centers of a Greyhound admin server can also fetch the topic configuration. We have a zookeeper listener cache that gets continuously updated with the current topic configuration. And you may guess it, how do we return back the information to the browser? We use the WebSocket service that I showed earlier, and it knows exactly which browser and which data from which location globally to bring back the information to. It also utilizes Raven for cross-DC communication. And I think you can see that Wix has embraced Kafka for large-scale asynchronous event-driven design in many areas. And we have all the required tools in place to support it, both for development phase, for the continuous integration phase, for production monitoring, for production development across the board. We created the stuff that allow us to increase the scale, increase the amount of developers that can handle this event-driven design. So that's it. Thank you very much. I uploaded the slides to SlideShare if you want to have them. And you can also follow me on Medium and Twitter for getting more updates on everything we do around Kafka and event-driven architecture and the data streaming team in Wix. So that's it. Thank you very much.